Good morning, everyone. In today's session, we will discuss how an ECG machine works, one of the most fundamental topics in electromedical technology. The electrocardiogram, commonly known as ECG or EKG, is one of the most widely used diagnostic tools in hospitals. Understanding its working principles is essential for electromedical technicians, as ECG machines are used daily in many clinical settings. An ECG machine is a medical device that records the electrical activity of the heart over a period of time. The heart functions as an electrical pump. Each heartbeat is initiated by an electrical impulse that causes the heart muscles to contract and pump blood throughout the body. These electrical signals are very small, but they can be detected on the surface of the skin using special sensors called electrodes. Let us begin with the basic principle of ECG measurement. When the heart generates electrical impulses, these impulses spread through the body tissues and reach the skin. By placing electrodes at specific locations on the patient's body, the ECG machine can detect differences in electrical potential between these points. These potential differences are then amplified, processed, and displayed as waveforms on a screen or printed on paper. The electrodes play a crucial role in ECG measurement. Electrodes are usually attached to the patient's chest, arms, and legs. Before placing the electrodes, the skin must be cleaned to reduce electrical resistance. Conductive gel is often used to improve signal quality. Poor electrode contact can result in noise, weak signals, or inaccurate readings, which is why proper electrode placement is very important. Once the electrodes detect the electrical signals, the signals are transmitted to the ECG machine through lead wires. These wires connect the electrodes to the internal circuitry of the device. The ECG machine uses different lead configurations, such as limb leads and chest leads, to view the heart's electrical activity from different angles. Each lead provides unique information about the heart's condition. Inside the ECG machine, the detected signals first go through an amplification stage. The heart's electrical signals are extremely small, typically measured in millivolts. Therefore, amplifiers are used to increase the signal strength without significantly increasing noise. High-quality amplification is essential to ensure accurate and reliable ECG recordings. After amplification, the signals undergo signal processing. This includes filtering to remove unwanted noise, such as muscle movement, electrical interference from power lines, or baseline drift caused by patient movement. Modern ECG machines use digital signal processing techniques to improve signal clarity and stability. Once the signals are processed, they are sent to the display and recording system. The ECG waveform is shown as a graph with time on the horizontal axis and voltage on the vertical axis. The waveform consists of several key components, including the P wave, QRS complex, and T wave. Each component represents a specific phase of the heart's electrical activity. Doctors analyze these waveforms to identify abnormalities such as arrhythmias, ischemia, or myocardial infarction. From a functional perspective, the ECG machine performs four main tasks: sensing, amplifying, processing, and displaying. These tasks must work together accurately to produce a reliable ECG recording. Any malfunction in one stage can affect the overall quality of the result. Electrical safety is another critical aspect of ECG machines. Because ECG electrodes are directly connected to the patient, strict safety measures are required to prevent electric shock. ECG machines are designed with electrical isolation and very low leakage current. This ensures that patients are protected even if a fault occurs inside the device. For electromedical technicians, understanding these safety features is essential during maintenance and testing. Modern ECG machines often include additional features, such as automated interpretation, data storage, and network connectivity. Automated interpretation uses software algorithms to analyze ECG waveforms and provide preliminary diagnostic suggestions. While these features can assist doctors, they do not replace clinical judgment. Technicians must ensure that the software is functioning correctly and that the ECG data is accurately recorded and stored. Maintenance and calibration are also important in ensuring proper ECG machine performance. Routine maintenance includes checking cables, electrodes, paper quality, and battery condition. Calibration ensures that the voltage and time scales of the ECG display are accurate. Incorrect calibration can lead to misinterpretation of ECG results, which may affect patient diagnosis and treatment. In clinical practice, ECG machines are used in various settings, including emergency departments, outpatient clinics, and intensive care units. In emergency situations, ECG recordings must be obtained quickly and accurately to support rapid decision-making. This highlights the importance of proper training and equipment readiness. From the perspective of an electromedical technician, your role includes not only maintaining the ECG machine, but also supporting clinical staff. This may involve explaining basic operation, troubleshooting common problems, and ensuring that the device is available and functional when needed. Effective communication with doctors and nurses is therefore an important professional skill. In conclusion, an ECG machine works by detecting the heart's electrical activity through electrodes, amplifying and processing these signals, and displaying them as interpretable waveforms. Understanding how each component and process works is essential for students of electromedical technology. By mastering the principles of ECG operation, safety, and maintenance, you will contribute directly to accurate diagnosis and high-quality patient care. Thank you for your attention. I hope this session provides you with a clear and practical understanding of how an ECG machine works and prepares you for hands-on experience in clinical environments. Answer the multiple-choice questions based on the tape. 1. What is the main function of an ECG machine? A. To measure blood pressure. B. To record the electrical activity of the heart. C. To control heart rate. D. To monitor oxygen saturation. 2. Why is the heart described as an electrical pump in the listening? A. Because it uses external electricity. B. Because it generates electrical impulses to pump blood. C. Because it stores electrical energy. D. Because it requires batteries to function. 3. What component is used to detect the heart's electrical signals on the skin? A. Sensors. B. Transducers. C. Electrodes. D. Leads. 4. Why must the patient's skin be cleaned before placing ECG electrodes? A. To improve patient comfort. B. To reduce electrical resistance. C. To prevent infection. D. To reduce heart rate. 5. What is the purpose of conductive gel in ECG measurement? A. To protect the skin. B. To increase signal speed. C. To improve signal quality. D. To reduce electrode temperature. 6. What do lead wires do in an ECG machine? A. Store ECG data. B. Display ECG waveforms. C. Connect electrodes to the machine. D. Filter electrical noise. 7. Why are different lead configurations used in ECG recording? A. To reduce power consumption. B. To shorten examination time. C. To view the heart from different angles. D. To increase patient comfort. 8. Why is amplification necessary in an ECG machine? A. Because heart signals are very large. B. Because heart signals are very small. C. Because ECG paper needs high voltage. D. Because electrodes produce weak sound signals. 9. What is one function of signal processing in ECG machines? A. Printing the ECG results. B. Removing unwanted noise. C. Storing patient data. D. Increasing heart rate accuracy. 10. What does the horizontal axis of an ECG waveform represent? A. Voltage. B. Frequency. C. Heart rate. D. Time. 11. Which ECG waveform component represents ventricular depolarization? A. P wave. B. T wave. C. QRS complex. D. ST segment. 12. Why is electrical isolation important in ECG machines? A. To improve image quality. B. To reduce machine size. C. To prevent electric shock. D. To increase signal speed. 13. What is the main purpose of automated interpretation in modern ECG machines? A. To replace doctors. B. To store ECG recordings. C. To provide preliminary diagnostic suggestions. D. To control patient movement. 14. What could happen if an ECG machine is not properly calibrated? A. Faster ECG recording. B. Misinterpretation of ECG results. C. Improved signal clarity. D. Reduced electrical noise. 15. According to the listening, what is one responsibility of an electromedical technician? A. Diagnosing heart disease. B. Prescribing medication. C. Maintaining and troubleshooting ECG machines. D. Interpreting ECG waveforms clinically.